Hi guys, and welcome back to our channel.
Today we'll be showing you guys exactly how our contestants are preparing for the buffer games. Dun, dun, dun. So, today the contestants are making buffered solutions. Now, you guys are probably wondering what a buffer is too.
Yeah, what is a buffer?
I don't know. Just kidding! So, a buffer is a solution that can absorb large amounts of acid and base without its pH changing by a whole lot.
It is made out of a weak acid and its conjugate base, or vice versa, or a half titration with a weak acid or weak base with a strong acid or strong base.
Now, today's pH was set by the one and only Madam President Julian.
Oh.
So, the rules are simple. Create a buffer with a pH of 9 that can hold as much acid and base as possible before the pH changes by a factor of 0.5.
Before the competition commences, each district's residents must create their own buffer and then choose which buffer will represent them in the buffer games.
Now, let's slide on over to the lab.
Wait, hold on a second. We're missing something. Wait, give us one moment. Safety first! We're making a buffer to show you exactly how our contestants did it. We'll be using the weak acid, boric acid, and salt sodium borate.
After some intense calculations, we have finally figured out how much acid and salt to use.
Boom.
So, first we need to measure out 2 grams of sodium borate. With this electronic basket goes to 4 decimal places because we love being accurate.
Woo!
Nearly there. Ish.
Later.
Since the Weibo was 2.6 grams, the total mass is 4.6 grams. So we've got 2 grams of the sodium borate.
Boom.
0.324 grams of boric acid. Boom. So let's see, we're gonna get that total mass to be about 2.3 grams. And we got it.
Woo!
And there. Yes. And add distilled water. Now, we need, let's see, what about 10 milliliters of distilled water. So, let's go measure her out. She's over here. And mix her up. Distilled water's over here. That little squeezy bottle girl.
Hi, sister.
Hey, sister, look at her.
Is she thick?
Nah, she's squishy.
Do 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 do.
Boom. It's 10 milliliters right there. So we go, zoop, dump her in.
Cowabunga.
Now we grab a magic wand, JK, stir rod. Just stir her up.
Leviosa.
Leviosa, not Leviosa. This will take a while.
20 hours later.
Still stirring. Good enough. She stirred.
This is fine.
And she stirred.
This is thicky.
So let's head on back over and test this with some HCl.
Woo woo.
So here's a lovely beerette full of HCl. Now,
Okay, so Sister Francesca is gonna titrate this Sister Thicky right here
Yes, I
to make
will.
a buffer.
and we're gonna have a pH meter.
Dun dun dun. Before we see if our buffer is worthy of Miss Madam President Julian, we must test the initial pH. We are hoping to get it to be 9 using our fancy dancy Bluetooth pH meter. Let's see what our new pH is. Oh no. Oh no. It's too high. It's too high.
Ari, what's
too high.
Okay, we'll make this work. I'll be okay.
Are you sure? Are you sure?
We'll make it work. Okay. Ari went off to go cope and stuff like that, and we're gonna see if I can make this right. So we're just gonna test it with our 0.1205 molar NaOH. See how much it holds. So our initial volume of NaOH is 23.87. I'm going to write that down with so we know the exact volume we use. It's very important.
Not risk
Messing anything up now. Okay. Let's go. We got our pH meter in here permanently so we can see how much the pH changes. And let's go. Oh, and the pH is already changed. Oh, no. It's fluctuating.
Uh-oh.
Okay, it's low again. And, oh. There we go. So let's see what our new pH is. New pH. 10.18, exactly 0.5. All right. New volume is 29.10. Nope, not 1030. All right. We'll do calculations later. Now let's test the acid. 1.
Okay, time for day 2. So today, using the same techniques we used for the NaOH testing, we will be testing how much HCl our buffer can handle without changing by a factor of 0.5. So our initial HCl reading is 25.4. So as before, our initial pH is 9.68, as you can see on our handy dandy Bluetooth pH meter. So now we're just gonna add some HCl. Okay, I think that's enough. Let's check our handy dandy pH meter. So our new pH is 9.18, which is exactly 0.5 we need. So now the new HCl reading is 29.30. Okay, so now that we have that tested, we will now calculate the moles of each to see if our buffer is correct.
So we want to calculate how many moles of acid and base we're able to put into our buffer. And to do that, we're using molarity equals moles over volume. So, starting with the base, the molarity of our base was 0.1205 molar. Boom. And so we set that equal to the number of moles, X, divided by the liters of base that we used, which was 22.55 milliliters or 0.02255 liters. And so solving for X, simple algebra that you should already know, I sort of know it, was 0.002717 moles. That's a pretty good amount of base. The same thing for HCl, we use 0.1018 molar HCl with 11.6 milliliters of HCl or 0.0116 liters. And solving for X, we found our moles to be 1.18 times 10 to the negative third. Also, pretty good amount. So, let's see how this base compares to our opponents.
Okay guys, I hope you enjoyed this vlog today. If you enjoyed this, please subscribe to our channel and hit that notification bell.
We're gonna smash that notification bell, slam that like button.
You know, the usual, so you get notifications when we upload, because you know, our videos be too good. Join the fam in here.
Boom. Don't forget about our merch. We got our merch going.
Yep, you know.
Yep.
Enjoy that fit,
merch.
cop that merch.
All right, first, before we end this, we need to talk about our mistakes. Hopefully we won't get executed.
We're very sorry we made these mistakes.
Yeah. Okay, but our first mistake that we made today was that we had way too much base in our buffer, which, you know, caused our pH to be too high because there was a concentration of OH was too high, so that caused our pH to be too high, and it could have absorbed more base if our pH wasn't so high. So that was
I really hope we don't get executed for that.
We better not get executed.
I really hope we don't.
This is like a goodbye.
So
segment,
goodbye,
not our
guys.
video.
This
You know,
might be our
goodbye.
last video.
Because next thing you hear about us is we're gonna be on the news and be like, breaking news: 2 vloggers got executed by Julian because their pH was too high.
Yep.
Yay!
This might be our last video, guys. I hope you enjoyed it.
Anyway,
so our second source of error.
Another reason for Julian to execute us.
Yep. Sorry, guys. Is we spilled some acid when pouring into the beaker, and it caused the pH to be too high.
Yeah, don't want to spill any. We spilled acid and we're pouring it from the balance to the beaker, pouring it, and some of it spilled, and so didn't have enough acid in there.
So altogether,
Again, pH too high.
that caused us to be executed from the games because it was
So
just
now
not what
you
we
know
wanted.
why you will not be seeing another video from us next week.
Yeah, so if
Farewell.
we aren't executed, please remember to smash that like button
They
and
can still
hit that notification.
smash the like button, in our memory.
I remember you smash
Subscribe
that
to
like
this
button.
channel in our memory, even though you won't get any notifications from now on.
Just have a good day, guys.
Yeah.
Bye.
Farewell. Hey, there they are.
Okay, guys, I hope you enjoyed this YouTube video and enjoyed our vlog.
Ta-da!
With 8
We never split it.
Oh no!